morning. I would like to introduce you to Pam Knox. She is the director of the University of Georgia Weather Network and agriculture climatologist. In that role, she's provided outreach and education on climate and its effects on crops and livestock. She is also an active certified consulting meteorologist in the areas of metallurgy and climatology, and the author of the Southeast chapter of the 5th National Climate Assessment. Pam, thank you so much for joining us.
I'm delighted to be here. As you can tell, I do a lot with agriculture. I do less with gardens, but I am one of the authors of the Garden Professors blog. And so I do occasionally, about once a month, write a blog post about climate and how it impacts gardens. My yard is mostly trees, and so I don't do a lot of gardening there. Usually when I come home from work, I just want to go sit down. But but I understand gardening can be very relaxing, and so I'm really glad to talk to y'all today. You will hear me often say things about agriculture, but really I'm talking about anything that has to do with growing plants. And if I seem just a little bit distracted today, it's because we're having a hurricane hit Georgia tomorrow evening. And so I've already done 4 interviews today, and I haven't had that much caffeine, but all that adrenaline is just kind of running right through me right now. But I'll do my best to keep it, hey, not too jittery, and we'll get through this all together. So let me go ahead and launch right in. Let's see. It's going to let me move. There we go. Didn't like something I did. So what I want to talk about in the time that I have here, I'm going to first just talk generally about what climate is and how it's changing. Then I'm going to talk about how those climate changes are affecting agriculture and garden plants. I'm going to talk a little bit about how ag and climate changes are affecting food security and outdoor workers, because gardeners, in one respect, are outdoor workers. And also a little bit about health. I want to talk about the opposite way, how agriculture is affecting climate. And then a little bit at the end about how we can work to help keep climate change from getting worse. So that's kind of the outline of what I'm going to look at over the next 30 to 40 minutes. First of all, let me just start off by talking about what is climate. If you ask the average person on the street, they'll probably say, oh, it's the average weather, which is true, but it's a lot more than that. Climate describes the atmospheric conditions that are going on in a place over time, and it also can be over space. So I've got 2 different examples of how you might depict climate here. One is a timeline on the top there. This is for Georgia, and this is the annual average temperature since from 1895, when records really started for the country as a whole, to the last full year, 2023. And I could probably talk for 10 minutes about just this graph, but I'm not going to do that. But I think there's some interesting things to see in it that I'm just going to point out briefly. One is that whatever happened last year is probably not what's going to happen this year. That's one of the joys and concerns about gardening, is that you can never assume that it's going to be the same way next year compared to what it is this year or what it was last year. There's the average climate is still going to be the average climate. That plant hardiness zone doesn't change that fast. But there's still going to be variations from one year to the next, sometimes from one season to the next, or even from one week to the next. And all those things are important for talking about gardening and growing plants in general. You can see, if you look at this one for Georgia, that there's a period where the temperature is rising early in the record, then there's a decline from about 1925 to about 1970 or so. That turns out to be a human-caused decrease in temperature due to increased amount of coal dust in the atmosphere, and also land use changes because the atmosphere became more opaque. We had burning a lot more coal. Of course, that was before the Clean Air Act, and so there weren't a lot of controls on what was emitted from the smokestacks. And here in the Southeast especially, we got a lot of blackening of the skies, and that kept the temperatures down somewhat. And when the Clean Air Act came in 1970, thank you, Richard Nixon, things got cleaner in the atmosphere, and our temperature here in Georgia in the Southeast started to go up again. over time, and really the whole rest of the country did as well. If you're interested, the website that's at the bottom there will allow you to go in and put something for your own location. And I know I've got people here from different parts of the country, so you can do that. The county average temperature rank map on the bottom shows that climate can also be described of spatially. And it's not going to be the same everywhere. If you're talking to a relative that's on the other side of the country, they could be experiencing quite a different local climate than I am here in the Southeast, or that you are wherever your location happens to be. So climate is not only described by averages, but it's also described by extremes, by ranges of temperatures and precipitation. There's, of course, cycles. We know the regular seasonal cycle. There can be multi-year cycles here in the Southeast. The biggest cycle is probably from El Nino and La Nina. And then, of course, there's also trends over time, and you can see that in the time series map. So all of those things together define what climate is, and we have to really sort of look at all those when we're looking at how climate is changing. I just picked Atlanta here because it's a city that's close to where I am in Athens. This is a graph that's called a thermograph. Thermograph shows the annual average high and low temperature as that green band. So you can see temperature goes up in the summer, as you'd expect, and goes down in the fall and winter. And then the red lines are the daily extreme temperatures for Atlanta for their period of record. They have a long record because the city's been around a long time. And then the blues are the extreme lows for each state. And you can see that there's a lot more variability in the winter than there is in the summer. That's not surprising because you get these cold outbreaks that come from the Arctic, or you can have spells of really warm air coming in off the Gulf of Mexico. And then superimposed on that, the gray bars are what is actually happening this year in 2024. So you can see there's a lot of variability in the spring. It really settles down a lot. In the summer, we don't have nearly as many big swings in temperature in the summer because the cold fronts and warm fronts are usually far to the north of us, up in the Midwest, for example, where I'm from. And then we're just starting now to go back into the time period when we start to get these larger swings in temperature and severe weather and precipitation and so on. One of the things you do notice on here is that overall, the low temperatures are above the long-term average nearly every day. There's a few time periods when they're below, but that's just a sign of the warming trend that we've been seeing since 1970, that on the average, the temperatures, the daily range of temperatures is increasing. Both nighttime and daytime temperatures are rising. Although it turns out that nighttime temperatures are rising at about twice the rate that daytime temperatures are. And that's because it's related to humidity. Humidity keeps the temperature from dropping as much at night. And so you might see this in your own, if you do any record keeping of your own weather, when it's really dry, the dew points are low, the relative humidity is low, the temperature at night tends to go down. It gets a lot cooler. It usually feels nicer, especially in the summer. And then if it's warmer at night, if the humidity is high, you just don't get those temperatures going down quite as much. So we've been quite humid in 2024, and you can see we're just not really dropping the nighttime temperatures that much at all. And so again, there's a website there that you can use if you're interested in seeing a thermograph for your own area. You do have to sign up for this. It's a free sign up to get a user ID if you're interested in that. But it contains a lot of information, so I think that's useful. If we look at time series now and this is for the contiguous US, so the lower 48 states, you can see temperature across the country has generally increased over time. There's a period there, just like there is in Georgia, where the temperature is going down a little bit, but since about 1970, it's definitely gone up, although there's a lot of variability from one year to the next. Precipitation, the annual average precipitation in the green there in the middle, is also going up, although maybe not quite as much as the temperature, but that's partly just the way you graph it as well. So we are overall for the country getting wetter. If you broke this down by parts of the country, not all parts of the country are getting wetter, but I'll show a map for that in just a minute to show what the variations are. And if you look at the Palmer Drought Severity Index, how often we have these really dry conditions leading to drought, I think you can see that early in the record, there's a lot more yellow. Those are the dry periods. Then there's green. And since we've gone to more precipitation, we are getting more values that are above normal for and not as droughty. That doesn't mean the droughts that we do have are as bad. There's certainly some very long ones, very persistent ones, and some pretty severe ones. But of course, a lot of those are more local. They're not necessarily something that covers the whole country. So it looks a little different if you're looking at one particular location. But you can go into the Climate at a Glance tool there and pull something up for your own location if you want to. But overall, right now, we're seeing a decrease in drought, both the frequency and the intensity. Good news for farmers, I guess, and for gardeners. So how is the climate changing now? This is all based on historical information. So that's nothing to do with models or anything like that. It's just what we've observed over time, except here it's shown as a spatial map rather than as a timeline. And you can see if you look on the left at the annual temperature, almost everywhere in the United States, the temperature is going up. Some places it's going up more, other places less. And you can see there's an area in the southeast where it's actually blue, where overall that temperature this is, I think, from like 1900 to 2000, has gone down. Now, if you added in the 2000 to 2024 values, a lot of that blue would disappear because we've been getting more warm years that have come in, and that what we used to call that the warming hole. That warming hole has mostly gone away if you include the most additional information. But I like the way this was laid out for using on the slide, so I continue to use it. If you look at the comparison between winter and summer temperature changes, winter is getting warm much more than summer is. And a lot of that summer cooling is happening in the central part of the United States. You might wonder why that is. And I think probably the number one cause of that is that there's increases in growing corn. There's increases in irrigation. And both of those things put out a lot of water vapor. Well, that keeps that keeps the air temperature down a little bit during the day. So if you have crops that put out a lot of water vapor, they use a lot of water, then you're probably going to keep things a little bit cooler that way, rather than just having xeriscaping or something like that. So temperatures are definitely are increasing across the U.S. as a whole, and in most of the U.S. individually, but not as much in the summer as it is in the winter. Precipitation here is broken down by seasons. You can see if the annual precipitation across the U.S. in most parts is increasing over time. That's similar to what we saw in the graph on the last page. And there are a few places where it's not. Southeast is one of those. That's because I think we've had quite a few droughts in the last 20 years or so. So that's kind of brought that down a bit. And of course, the desert Southwest, where it seems to be getting quite a bit drier, in spite of the fact that they've had some really wet years, occasionally interspersed among all the dry years. If you look at it by seasons, winter, variable. A lot of the western part of the United States is getting drier. If you look at spring, a lot of the northern part of the United States is getting much wetter, whereas the southeast is getting drier, and so is the southwest. For precipitation, a lot of the bigger increases in precipitation are where a lot of the crops are growing. And then in fall, you can see there's a huge increase in precipitation on the East Coast and up in the Midwest as well, whereas the West is, again, more dry. So whatever you're experiencing may or may not be similar to what's happening in another part of the country. And that's important to keep in mind. Not all the trends are going to be the same. They can be related to things like how are the ocean temperatures changing. That's would be especially true if you're near an ocean, if you're on the West Coast, for example, or if you're down in the Southeast where you've got the Gulf of Mexico contributing to whatever your temperature and your precipitation is. But trends are generally increasing as far as precipitation, but certainly not everywhere. So how is temperature expected to change in the future? This is where we start to get into the realm of computer modeling. Now, computer modeling for climate is similar to what we do when we do computer modeling for weather forecasting. Like if I want to know what the weather is going to be like in a week, or if I want to know where this hurricane is going to go, they use computer models to really try to figure out what's going to go on. This is similar to some kids' games like Planet Earth. And you can change different things and see how that will affect the climate in a particular place. This shows for different scenarios what the projected changes in the annual average temperature are likely to be about 2050 and about 2100. So the top ones are mid-century, the bottom ones are late century. And there's two scenarios that RCP 4.5 is an increase in temperatures, assuming that there's a lot of work being done on keeping the amount of carbon dioxide out of the atmosphere. RCP 8.5 is kind of the worst case scenario where people are not making any changes at all. We already know that's not going to happen because there are people making changes. They're driving more electric vehicles or hybrids at least. They're changing to be used more energy efficient in other things like refrigeration. So we're probably leaning more towards RCP 4.5 rather than 8.5, but it's interesting to see what the difference is. What we're going to see in the future really depends on how much carbon dioxide we add to the atmosphere. What's in the atmosphere now is really not going to completely affect the temperatures until about 30 years from now. It takes a while for all that thermal inertia to work in. You can see that the changes are most likely to occur up at high latitudes, and that's because that's where the most snow is. So, if you go outside into a field of sunny snow, brand new white snow, you get most of the light just gets reflected back to you, and it's very bright. So if you take away that snow, all of a sudden it becomes much darker. And those areas up at high latitudes are where most of the snow is and most of the reflection is occurring. As it gets warmer and that snow disappears, then they are able to warm up much more because they don't have the snow helping to keep the energy balance there from changing. And so that's why when we look at the impacts of things like sea ice changes, sea ice is also very reflective. That's changing temperatures much more than some other things because it changes how much sunlight actually gets to the ground. The average temperature is the easiest thing for climate models to predict. They've been looking at the effects of carbon dioxide for over 100 years. And it's pretty simple calculation to do. There are people who calculated it back in the 1800s and were able to come up with a pretty good estimate that if you add so much carbon dioxide to the atmosphere and other greenhouse gases, you will get a 2-degree Fahrenheit warming in the temperature. And they've been surprisingly accurate. The problem is average temperature is not very useful for most people because we're more interested in the daily temperature. We're interested in things like the growing season. We're interested in, what the extremes are going to be. So average temperature doesn't really capture any of that. And that makes it a little harder to use when we're talking about what's going to affect things like gardens in the future. How precipitation is expected to change. Precipitation is a much trickier thing to deal with because precipitation depends on water availability, it depends on temperature, depends on the vertical structure of the atmosphere. So that's a much trickier thing to do, and the models are much less consistent in what they expect is going to happen in the future. On the left-hand side here, it shows the projected changes by seasons of precipitation across the North America. And you can see that for almost every season except summer, we expect precipitation to increase. And we've seen that in our data of the past, we expected it to increase, and that's likely to continue to increase, at least in winter, spring, and fall. Now, here in the southern part of the state, it's a little bit less likely. If you're in the Mountain West or if you're in the Southwest, summer especially is going to be more dry in the future. But areas that are farther to the north are areas where they're probably going to get more rain. And we're starting to see this in agriculture because there are places in eastern North Dakota, for example, where they could only grow wheat before because wheat doesn't require that much rainfall. But now, because the rainfall is increasing, they're starting to be able to grow corn, which needs more water. And so some of those things are starting to change in agriculture, and we expect to see those changes in the future. Water supplies obviously are related to that because you need a place to supply water to whatever population you have, as well as for irrigation. Those may be more variable or less available. If it's warmer, you're going to get more evaporation off of reservoirs. You're going to get people who might need more irrigation for crops as well. So all those things are questionable. They're harder to figure out. And of course, human demand is also something that's very hard to model. Hard enough to model weather, but if you're trying to model human behavior, it's much harder because they're not very rational a lot of the times. We do know there's going to be less snow or ice in most areas because it's going to be warmer, but they will have more heavy rain in the summer. And we're starting to see that also in the Arctic, where they're having some really heavy rains. This year they had some really heavy rains in the northeast part of the United States and on into Canada. And that's something that's likely to happen more often. Infrastructure is really not built to handle those heavier rains. If you have culverts or if you have drains on your roads, those things cannot handle the heavier rain very well. So you're more likely to have flooding of the local road systems as well. The map on the top right shows the change in the number of days with 2 inches or more of rain in 24 hours. And it's just broken into different regions of the United States. You can see in the Northeast, they expect the number of days with 2 inches or more of rain to increase by 71%. And so that's going to be many more days that have really heavy rains. Down here in the Southeast, 27%. Now we're supposed to get up to 8 inches in the next 2 days from Hurricane Helene. And so, it's obviously not just linked to hurricanes, but linked to other kinds of weather patterns as well, weather systems that come through. For the Northeast, I think at least part of it is because you're going to get more rain instead of snow. And so that's going to change how it falls as well. And so that's something that we really keep in mind. But infrastructure is going to be a huge issue. Most designs for infrastructure in cities were built 50 to 100 years ago, so they're way behind in terms of keeping up with even the current climate, much less the future climate. And that's going to be more of an issue, I think, in the future. So how does climate change affect agriculture? There's a bunch of different ways, and agriculture includes gardening here. If the average climate conditions will determine what kind of plants that grow at a location. I'll talk about the plant hardying zones in just a minute. Obviously, there's other factors too. We're talking about this before we started the webinar. The soil type is a really important thing. What kind of shade you have, whether for agriculture, you have to worry about whether you have a way to transport your goods to market, availability of water, if you have irrigation or if it's all, dry land will make a difference. Climate variability is good for ecosystems. A lot of ecosystems are adapted to having periodic droughts or having periodic floods or fires, so that there are certain plants that really require that to propagate. But for most people that are doing agriculture or doing gardening, you want things to be kind of the same from one year to the next, because that's the best for the plants that you would pick there. And so agriculture and gardening generally prefer the climate to be roughly the same every year. Now you can obviously adapt to that by watering and so on. So it's not set in stone that that's the only thing, unless you're doing gardening with no irrigation at all. But climate variability is a little different for gardening than it would be for ecosystems. Some of the other things that is affecting growing plants, extreme cold. If you have frost and freeze, that often determines the length of the growing season. From the last frost in spring to the first frost in the fall, that's usually the length of the growing season. Depending on the plant, it could be 32 degrees, could be 28. I think for most people, they usually use 32. Extreme heat. Really high temperatures are not good for some plants. Corn doesn't like it, for one. Corn doesn't like to be above about 86 degrees Fahrenheit. Humidity can also be a problem, because humidity will provide more fuel, if you will, for like mildew, powdery mildew, or other fungal diseases. And it also will affect some other kinds of critters, some kind of pest that will come in, or will also affect the likelihood of certain kind of weeds that grow. But the extreme heat also affects things like pets and livestock. If you're outside a lot, you have to keep that into account. If you work outside a lot as a gardener, of course, you like to be outside, maybe not in the hottest part of the day, but certainly you want to be outside working. And you have to consider there are probably times, especially if you're in the southern half of the United States, where it's probably not ideal to be out, because it's so hot that unless you're drinking a lot of water, you run into the risk of maybe running, into some heat diseases. And so those are the kind of things that are important for gardening that aren't really captured by averages. And so that's why we look at all that. Climate change is affecting those, and they're not all in essentially linear ways, because some of these things, frost and freeze is really related more to weather than it is to climate change. And so the way that the weather changes may not exactly mirror what's going on with the climate. So we look at how climate change is affecting plant growth. In particular, longer growing seasons could mean more plant varieties. You can plant something earlier in the spring and have it last through the fall, but it also means that there's more likelihood of having pests and diseases that you have to deal with if you want to keep your garden healthy. Um, we see this a lot in agriculture here in Georgia in the winter. We're expecting to have a pretty warm winter this year because we're in a La Nina, or we will be soon. And that means a relatively warm and dry winter, but there's a lot of things that like to overwinter, and they can live on kudzu, or they can live on some other weed crop, and then get right back into the crops again when they start growing in the spring. A lot of pests can bury underground, and then if it's not too cold, they'll come out again in the spring, and they start to infect the plants much sooner. Warmer winters are going to affect things like fruit production. I don't know if any of you have fruit trees or not. Um, most fruit trees require a period of cold weather to set their crops. We call that chill hours. And the chill hours, different varieties of plants have different chill hour requirements. And so here in Georgia, of course, we're known as the peach state. The peaches all require a certain amount of cold weather to really set a good bloom. It's important to do this because you want them all to bloom at the same time for commercial development, because a lot of times people are going to bring in bees. They want to pollinate the whole orchard at once. And they want to be able to harvest the whole orchard at once too, because it's much more efficient than going back 3 or 4 times and harvesting just what's ripe. So they're really working hard to make it easy from a production standpoint to do that. We have warmer winters. We are less likely to get enough chill hours for some of the varieties. So you have to adapt to that by planting varieties that require less cold weather. That does make them a little bit more vulnerable if we have a late frost. And we had that 2 years ago and lost 95% of our peaches because it was really warm over the winter. And then everything started blooming, and we had a late frost. It really wasn't that late, it was mid-March, but it caused tremendous damage to the main part of the peach orchard belt in the center part of Georgia, and lost most of the crop. We did have some people that were more in southern Georgia or more in northern Georgia where they had different varieties of peaches that did a little bit better, but the commercial crop just didn't really work very well. So warmer winters can change fruit production. This would be true also of any crop, any fruit crop that requires an amount of cold. This could be apples, could be cherries, could be blueberries. Actually, in Georgia, we grow many more blueberries than we do peaches. But it's called the peach crop because historically we produce most of the peaches over time. We have more dry days, means we're going to have more irrigation. If we have the same number of days, except that if we have the same amount of rainfall in a year, but it's only in a few days because we're getting these really heavy rain events, then there's going to be longer dry spells in between. And you can actually show that the number of consecutive dry days down in the bottom left there is increasing over time. So we're having longer dry spells. And when you're working in a garden, they have to have regular rain. And if they don't, then the plants really start to suffer. And so if we have more consecutive dry days, we're going to have to think about more irrigation or some ways of getting water to them, or changing to a different crop that requires less water. We do expect to see more hot nights. That's going to be a problem for livestock and pets. A lot of workers aren't really out at night, so not as much of an issue, unless they're working at night because it's even hotter during the day. And there is some of that going on now as well. Higher carbon dioxide. One of the few things that's good about adding carbon dioxide to the atmosphere is that carbon dioxide does act a bit as a fertilizer. And so it does cause some increases in the growth of plants. Problem is, the plants that are most affected by increases in carbon dioxide are things like poison ivy. You probably don't want more poison ivy in your gardens. And so we do see some fertilization from increases in carbon dioxide, but it's probably not going to be much. It's going to be much more affected by things like water availability. And so all of these things are things that you have to think about when you're thinking about your garden. What are you going to plant that's appropriate for your location? Because every garden has its own microclimate, which may be similar to what is in the surrounding area, or it could be different. If your garden is on the south side of your house, it's probably warmer than if you put the garden on the north side of the house, where you've got more shade and more protection from southern winds. And so all that stuff needs to be taken into account, and it's all going to, factor into what kind of plants you can plant and grow successfully. Now, I mentioned we're going to talk about the plant hardiness zone. Plant hardiness zone is something that comes from U.S. Department of Agriculture. This is the map as of 2012. And you can see that plant hardiness here is divided into zones. There's a 1A, 1B, 2A, 2B, and so on. Each of those, the 1 is like a 10-degree zone, the coldest minimum temperature you can expect to occur in a year in that location. It's divided into A and B. That's kind of like 5-degree subsets. And you can look on here and you can see how the plant's hardiness zone changes over time. Generally tracks with the annual average temperature across the United States. And I'm sure if I asked all of you, could probably tell me what your plant hardiness zone is, because that's the number one way you pick a plant to put in your garden that's going to tell you whether it's suitable to grow there or not. And obviously, again, depends on microclimates over time, but that it's really related to how much cold temperatures that plant can take and still survive. And that's related mostly to the minimum temperature, which is mostly a winter temperature, of course. Last year, there was a change to the U.S. plant hardiness zone map. The 2023 map is shown here on the right-hand side, and I put the change map here on the left. So you can see that really most parts of the United States changed by 1/2 category. So they went from 1A to 1B or something like that. So that means basically about a 5-degree difference in the lowest minimum temperature. And that's definitely a reflection of those rising temperatures over time. You can see some of the changes there across the United States. There's a few areas in the West that are showing green, which means that they actually got to a colder plant hardiness zone. That's probably more just because they brought in more data than they had before. Not necessarily that the climate there is changing, but they have a better description of what the actual climate is at those locations. So you can go in the website here at plantHardiness.ars.usda.gov as a zoomable map, so you can zoom in on your location and see what the plant hardiness zone is for your location if you don't happen to know it already. But this is something that's related to temperature. Doesn't say anything about precipitation at all, just about temperature and just about the minimum temperature. So it doesn't really say much about the maximum, because it doesn't really talk about, whether a plant can survive really hot conditions or not, although I think most gardeners would agree that's an issue. But it does not show up as part of the plant hardiness calculation. We look at what's going to happen in the future. This is a projection of what the plant hardiness zone will be like in about 50 years from now. There are some changes. I know in Georgia, the zone 9 has crept up farther. They don't really show Atlanta here, but I think Atlanta already, there are places in Atlanta where it is already almost a 9, because we have the urban heat island there, as well as the warming temperatures overall. But you can see that there are expected changes in plant hardiness. If you're planting something that's going to last for a long time, or you want to be a perennial, then you have to think about longer term changes. For example, when I talk to tree farmers, and trees, especially pine trees here in Georgia, are an agricultural product, not just something that you like to have around the house. They are planting trees now that are coming from Florida, because those trees are going to have to survive the next 30 years. And as the climate gets warmer, the trees that are coming from Florida are already adapted to warmer temperatures. And so that's how they're trying to deal with some of these changes in plant hardiness zone and temperatures already. So that's what it's likely to be in the future. Look at other things. This is the length of the growing season in the USA. You can see there's 2 curves here. One is for the West in blue, and the other is green in the East. both of them are seeing increases in the length of the growing season, a lot of year-to-year variability, but overall increase. The West is changing more than the East is by quite a bit. And that's probably because the West generally has more variability in the climate. And it's also, there's less adjustment by water because the water vapor from the ocean doesn't really reach as far inland. And so there's more desert lands there. So you can see more change in the West than there would be in the East. But both areas are increasing. Here in Georgia, one of the things we've known about that is that if you have a longer growing season, you can start to do things like double cropping. So you put in a crop early in the year, like corn or something like that, you harvest it, put in another crop like peanuts or cotton after that, and you can grow two things as a commercial crop instead of one. And that's really nice because then the farmers have two sources of income instead of one, which really mitigates against risk. Farming is not something I could ever do. It's very, you have to know a lot about a lot of things, not only the weather, but you also have to know about the cost of gas, the cost of fertilizer. You have to know about the war in Ukraine because that's where a lot of the fertilizer comes from. You have to know what's happening in other places. For example, if you grow soybeans, you need to know what's going on in Brazil because a lot of soybeans come from Brazil, so you're competing against them. So all those different things are factored in, but it does give farmers more options for growing different kind of crops because they have this longer growing season. And you will see in your own gardens, if you have a longer growing season, you can expect to get out and start planting things earlier in the year. People are always anxious to start working in their gardens again in the spring. Well, you'll be able to because the growing season will be longer. Spring will, the season that's good for growing garden plants will last longer, will start earlier and last longer. So you'll have more variety in what you can plant or how you do planting of cool season crops early in the year and then late in the year, and then the warm season crops in the middle. Either flowers or vegetables, depending on what you're growing. You look at the changes in the growing season by state. I pointed out, I think that the West is seeing much bigger changes. In the East, it's less. And poor Georgia kind of sticks out in this map. That's really an artifact of that cold pool that we had, the warming hole in the Southeast. That is going away. I expect when they do this next version of the graph or this map in about 2 or 3 years, it probably will be white and not brown, because we're kind of washed as the average of years gets longer. That cold period just gets to be a smaller and smaller part of the average. And so growing season is increasing everywhere. It's increasing more out west, and it's increasing somewhat less, especially in the Southeast. But that's all starting to catch up now. So that will be changing over time as well. We look at the timing of this last spring and the first fall frost. The spring frost is here in yellow. You can see that as time has gone on, last spring frost, last 32 degrees, is getting earlier in the year. And the first fall frost, which is here in orange, is getting later in the year. And this is related to that increase in the growing season, because those are kind of the bookends of the growing season. And so that is something that tells you, well, we can probably plant earlier in the garden than we used to, and we can expect to see things like our fall brassicas and spinach and so on still growing later in the year than they used to, because the frost won't come until later. So that's really something that's interesting to note as well. Fires are not something we talk about very often, but there's definitely a lot of fires out west. And really, people in the East ought to be more concerned with the prospects of wildfire, because we have a lot of trees. I'm on the tree commission in Athens, Georgia, and we try to keep our tree cover in Athens at over 50%. Many of you may live in areas like that as well. If we ever went through a really long drought, those trees could catch fire. We could have a forest fire even in suburban areas. And so that's something to keep in mind. We expect to see more fires in the future because as temperatures go hotter, things generally tend to dry out. And so they're more susceptible to things like wildfires. And that is something that we're concerned with. The West, of course, is the poster child for this, because the West already has all those trees. A lot of them are not they're not managed in a way to enhance natural fires, but they try to keep from preventing forest fires, and then it makes them more susceptible to the big ones when they do happen. We know that climate change is also the increase in temperatures is affecting migration of tree species to the north, as well as animals, birds and animals that live in those trees or live in those areas. Those are also moving towards the poles over time, or if you're in a mountainous area, they're moving up the mountain to a higher elevation where temperatures are more like what they want rather than what they're getting. And so all of those things are changing. Some areas could switch from forests to savannas or prairies. Those depend on uh, how much rain falls and how it falls, if it's all at once or if it's smaller amounts scattered over time. Starting to see a little bit of that in some places. And, with sea level rise, we can also expect to see some changes along the coast. We're already starting to see some coastal forests that die because there's saltwater intrusion into the land where those forests are growing, and the trees just can't handle the salt. And so they die off and it turns into coastal marsh, or eventually could become mangroves, just depending. And so all those things can be affecting the landforms that are associated with forests. I've worked with some foresters here in the Southeast that look at how do we pick the plants or pick the tree varieties that are going to do the best in a future climate. There's a website here called Pine Map, and Pine Map will look at what the weather is like in other parts of the Southeast and say, well, this is what we think it's going to look like here in the future. So this is where you ought to be getting your tree seeds from, or your little seedlings that you're going to put in the ground. And so they can use this, and they can also see the range. You see the lowest likely change and the highest likely change. So you can see the range of what options they have to work with, and picks appropriate varieties that will work for trees that are going to be in the ground for a long time. So for those of you who are planting trees and you want them to be in your yard for a long time, you have to think a little bit about what are the growing conditions going to be like in 30 years? Or is this tree going to still do okay? So that's something to kind of keep in mind as well. Foresters and gardeners are going to have to choose different species that will match what the climate is expected to be. If you're just growing cotton, it's not as important because you're putting in new cotton every year. But if you're growing something that's going to be there for a long time, either it's perennial plants or trees, you have to think more about what the climate is going to be like in the future. So if we look at how climate change is affecting landscapes in general, you get more extreme weather will cause changes in floodplains and stream ecology. You get, with this heavier rain, a lot of it just can't sink into the ground, so it's going to wash through the stream beds. That will cause changes in the ecology along the floodplains and the streams. That could cause some distress to species that live there. You could see more floods and more droughts because we're going to see more variability in rainfall over time, these more heavy rains and longer dry spells in between. Species are going to migrate to find hospitable climate. These are both good species and also bad species, especially invasive species. They're going to look for places that work best for them. And so that is something that you're going to constantly have to deal with, is these invasive species that love the climate you're in and compete with your garden plants to grow. And that's going to change over time. They're going to be moving as well as being introduced. Right now in Athens here, we have a lot of spiders that have been introduced. The Joro spider started, I think it came over on a freight ship from Asia, and it's been starting in Athens. I think it hitched a ride on some sort of truck, and now it's spreading throughout the Southeast and will probably be somewhere over time. And it competes much better than our local spiders do. So it's taking over the ecosystem. I mean, fortunately, they're not poisonous or anything like that, but they're a little scary because they're quite big. And so something that keep in mind. My yard is full of different invasive species like English ivy. And so that is something I work hard to try to get rid of, but boy, that's tough. And you're going to see more problems with invasive species coming in because they're going to look for the best place for for their plants to thrive. And it might not be, the kind of plants you want in your garden. So that's something to keep in mind. You get more extremes that could change the landscapes over the long haul. A lot of this, it may not matter to you if you're only going to be at your house for another 10 years or so. You might not see too many of these changes. If this is someplace, if you're young, you're planning to be there for a long time, could be more of an issue. Or if you want to hand a property down to your kids, you're going to be a little bit more concerned with what's happening long term. And so that's something to keep in mind. And also the problem is that some ecosystems that are on mountains, for example, may just disappear because it will get too warm for at the top of the mountain for those ecosystems to even exist. And so some things are going to just disappear. And that it's really a shame that, that's going to happen, but that's the way it looks under climate change. And unless we can turn it around, that's not probably going to be something that we can effectively stop. So all these things are things that, we talk about as climate change is affecting agriculture and growing plants. You're having more frequency of weather extremes. You're having some longer growing seasons in cool areas, but mostly, longer growing seasons across the whole US for the most part. More unpredictable farming conditions because you're going to have these longer dry spells. You're going to have more problems with pests and diseases. And you're going to have problems with rising sea level. So all these things are happening to affect what you're able to grow in particular conditions. Extreme weather, loss of coastal croplands if you're near a coast, and some tropical areas that are just going to turn into deserts. They're not going to be able to grow anything at all. The people that live there are going to move because they need to eat. And so they're going to move to somewhere where they can grow food, and that's going to cause conflicts between different populations. And so we expect to see more of that in the future as well. We look at it in terms of food security. Are we going to be able to feed ourselves in the future? We have more extreme weather. We're going to have more frequent crop losses. So we're going to have more problems growing things in the future. You can, as a home gardener, you can mitigate against that somewhat by doing watering. And it's smaller plots, so you're not going to lose as much as if you're doing commercial agriculture. Cost of food transportation is important for farmers because they can grow it, but if they can't get it to the market, they can't make any money off of it. So if food transportation is an issue, then that's going to cause more problems with food security. Changes in population mean more people to feed, and climate's changing in other lands too, in other countries. And so they're also dealing with all the same issues that we are here in the United States. And water is becoming harder to get just because there's more evaporation, but also there's more demand for it as the number of people go up. And water is also used in manufacturing and other things as well. So all those things are affecting our ability to grow enough food for ourselves. Also, other things like warmer winters. It's going to change how much fruit we're able to grow and where we're able to grow it. Could the intense hurricanes is on my mind today, of course, because it can destroy cotton, pecans, and other crops and cause really multi-year losses. A lot of the farmers right now in South Georgia are still recovering from Michael in 2018. They had to take out loans because, of course, insurance never pays for everything you lose in agriculture. And they haven't paid off the loans yet. They're starting if you lose your pecan trees, as you can see here, the second to left picture, they all blow over. It takes another 10 years before you can start really getting commercial production again. So a lot of those places are just now starting to see pecans on their trees in enough quantity to be able to sell. So that's a really multi-year loss for that family that owns that orchard. And you're going to have more problems with flooding because you can't sell food that's in a flooded field because you're worried about contamination. If you're growing food products, cabbage, or anything that grows on the ground, and you have a flood, you really are not supposed to sell it for sure because it could be contaminated by chemicals, or it can be contaminated by microbes that are in the soil and so on. So that's going to be more of an issue as well in the future. More frequent extreme events can cause disruptions in growing crops. For example, Hurricane Michael, as I said, caused almost $5 billion in just agricultural losses, but of course there was a lot of other losses in infrastructure and homes and everything too. In Georgia, we had about $2.5 billion loss to a bunch of different crops. I expect to see something very similar with Helene as it comes on shore tomorrow and Friday. We could lose as much again this year. It's tremendous loss for the farmers who do this for a living. Loss of power, we expect to see lots of power outages. At my house, the power goes out when the sun is shining, so I'm not sure what's going to be like on Friday. I may not have any power at home or at work. But it leads to losses of things like chicken houses and dairy production because they need power to keep the chicken houses ventilated. They need power to milk the cows. A lot of times they don't do it by hand anymore. And so all those extreme events can cause a lot of problems. And extreme events are going to cause problems even to the home gardener, because if you have a huge flood, if you had 8 inches of rain fall on your home garden, it's going to cause problems. It's going to wash out some plants. I mean, that water is not, unless you really have a nicely landscaped garden and you've got, a rain garden area where the water can drain into or something like that, you're going to see problems with it. And so that is something, as we get more extreme weather, that y'all are going to have to deal with. We look at changes in ag and climate and how they're affecting nutrition. Generally, if you have more carbon dioxide, it makes staple crops less nutritious and can't support the needs of a lot of people in the developing countries. And I know I'm running out of time here, so I'm going to run through these last slides quickly. Climate change is affecting livestock because cows don't like to be hot. They don't give as much milk, they eat less, they gain less weight, they're less fertile. And so I work here in a area that grows cattle. This is beef cattle here rather than dairy cattle, but you really have to worry about how that heat's going to change them in the future. You have to worry about how climate change and heat is affecting outdoor workers and safety. If you work outside, this is going to become more of an issue in the future. Or if you have gardeners that work for you, you're going to have to be careful that they get breaks for water and rest in the shade. It's in agricultural work, you get paid by how much you pick. And so they don't want to take breaks, but they're going to have to, or they're going to get sick and even potentially die. And if you look at how farming contributes to global warming, farming can do some good things like sequester carbon in the soils, but it can also use a lot of things that produce methane, which is a very potent greenhouse gas, and emissions from fertilizers, land use changes, and so on, all contribute to global warming. California is one place where I think, the really dry conditions are going to mean we're going to have to find new places to grow a lot of our commercial food. I think 97% of all the broccoli in the US is grown in California. And if they don't have water anymore, if it's all dry, it's got to come from somewhere else, or we're going to have to stop eating broccoli. Or possibly we're going to have to buy it from another country if they've got the right climate conditions for it. So that's going to be interesting to see how all this changes over time. Most agriculture in the center part of the US is used to grow animal feed, a lot of corn and soybeans. You can see along the edges, California, it's much more human food, and down in the southeast and in the very far northeast, more human food. But we're going to have to think about whether or not we want to grow food for animals or for people. And obviously some land is not going to be suitable for crop production. So you're going to still have some livestock production, but that mix is probably going to have to change. And since I'm going to use this as my last slide here. Says agriculture contributes about 24% of the greenhouse gases to the atmosphere. That's one of the places we really have to think about cutting our emissions of greenhouse gases in the future. So that's something we need to do. And I see there's a couple of questions. I want to try to get to those in the slide deck here. And if you need that, you can write me, or you can talk to the organizers or look at the recording and get this off, or just some places where you can get some more information. And this is my contact information as well. Let me see what the questions are in the chat, and I'll see if I can get to those. Okay, the first one, Ginny talks about on the East Coast, you're seeing ghost forests because of saltwater intrusion. Yeah, and I've seen a lot of pictures of that. If you're living pretty close to a coast, the salt, as people draw more water out for for municipal uses and so on. And as sea level rises, that salt is moving into the aquifers and it's really killing off the trees along the coast. And the other question from Brooke is, does Pine Map exist for other regions? Not that I know of. It was a pilot project done in the Southeast. There may be other ones out there. No, I'm not sure right now if there is, but I don't recall that there's been another one for other parts of the country. But that's no reason that you couldn't go in and say, well, this is what we expect the climate to be like in the future. Where is a place in the US that climate is already existing now? And what kind of plants grow there, and use that as a way of doing it on your own. So I'm going to stop there and see if there's any other last minute questions. I see I've got about 5 minutes to go.
You timed that to perfection.
Well, I hope to spend more time with questions, but you never know.